Hello, everyone. Today's topic is the design of a media content ecosystem. I will be speaking on the topic Case Study on AI generated content integration. We operate centering on the CDP, how AI generated content was integrated into the media content ecosystem. I will introduce the design concept and business contributions. First, allow me to briefly introduce myself. I am Yasuyuki Tanaka. I belong to the Media Platform Division. I am usually in charge of the CDP that handles media content such as news articles. As a data director in the media domain, I am also responsible for developing data utilization infrastructure and promoting governance. I myself have spent most of my career in the field of search technology and data infrastructure. Therefore, how should content be held in what form? I believe that will determine its scalability for many years to come. Today, I would like to explain such design decisions and our efforts to properly govern content data. Good day. I will speak in the following order. First, as background, I will explain why it was necessary to integrate AI generated content into the ecosystem. Next, as an overview of the ecosystem, it is centered around the content distribution platform. I will explain the content's cyclical structure. Next, regarding the system design, I will specifically introduce the three main platforms and their collaborative architecture. After that, business contribution, platform operations. I would like to conclude by discussing future prospects. First, I will explain the background. First, what exactly is AI generated content? Generally, regarding the differences in content for articles submitted by a media company. We aggregate comments and reactions to specific topics or angles. This refers to content generated by AI in the form of articles. In media services, including Yahoo News, in addition to article content, we are now also providing AI-generated article contents. To introduce specific examples, the first is a comment article. This is a summary of comments submitted to Yahoo News, organized by AI. The second is Buzz Summary. This is an AI-generated trend from Yahoo Real-Time Search. It will be aggregated content. It offers a different perspective than articles written by journalists. This initiative aims to broaden the range of information users can access by delivering insights into public reactions and trending topics. Next, I will explain why we integrate AI-generated content into our content ecosystem. So among the services provided by Inafusa, those that particularly handle article content are: there are many services such as Yahoo News, Line News, and the Yahoo Top Page. I introduced earlier AI generated content as well. These are pieces of content generated by different services, Yahoo News and Yahoo Real-Time Search. Suppose each service has its own content management and distribution system. Those, we want to link content between services and distribute it. Please imagine such a scenario. Whenever new content increases, individual support is required for all services that reference the submissions. I don't think it's realistic to implement that. That is why we centrally aggregate diverse content. There is an ecosystem as a platform that can distribute, search, and analyze. The goal we aimed for this time was to integrate AI-generated content into this ecosystem. On top of that, various services can be used and deliver content to users faster. And the platform is responsible, including managing the terms of use. Our goal is to establish these three things. What is the approach for that? Instead of adding a new dedicated pipeline for new content formats, it was about extending it. The integration of new content formats into existing ecosystems. It sounds simple when you say it. Before focusing on the technical implementation, we needed to pass three discussions. The first is data governance. It has become necessary to confirm the conditions under which data can be handled. Here, for AI-generated content, we organize the legal and contractual handling of original data and generated products, and determine the scope of integration. The second is integration with the platform. This is about aligning the constraints of existing infrastructure with new requirements. Existing infrastructure has usage restrictions that have been established through many years of operation. This is the process of deciding where to align with existing specifications and where to extend them. The third is coordination with ecosystem stakeholders. Because content owners and users each have their own requirements, the platform adjusts not only technical specifications, but also terms of use and operational policies. Only after these steps is technical registration initiated. Conversely, if the design is sufficiently abstract, then the technical work after obtaining these discussions can be minimized. This is why we chose the approach of extending it. Next, I will explain the overview of the content ecosystem. Against this backdrop and through these discussions, I will now explain the overall picture of the content ecosystem into which AI-generated content will be integrated. First, I will explain the scale of ecosystem utilization. Currently, 14 internal services submit content. This includes the Yahoo Japan app and Yahoo News, with 36 services, referencing the search and recommendation APIs. There are a great number of services available. This system consists of three main platforms. The first is the CDP. This is a platform for aggregating, distributing, bidding, and searching content. The second is the feature analysis platform. This is the foundation for extracting the meaning of content. The third is the search platform. This is an engine that responds to search recommendations. At the core of this ecosystem is the CDP. To manage ingested content, it collaborates with other platforms to establish the flow of the entire ecosystem. I would like to show you how these three are linked in the next diagram. This is a diagram illustrating the overall flow of the ecosystem. Content is submitted to this CDP from in-house media services, such as Yahoo News. Next, we perform content feature analysis. This configuration suggests content is recommended through search and then returned to the client. Then, the client logs the delivery results distributed to end users, which are then used for analysis and improving delivery logic. The core of this mechanism lies in two elements: content ID, and content schema. A content ID is assigned upon submission and is used consistently across all processes, from feature analysis to search logs. Content schema. It is a unified data structure defined by the content delivery platform, serving as a common language for all platforms. And one more thing I want to emphasize is this feedback loop. User browsing and compounding remain in the logs with a content ID. After analyzing the effects, we return to the search keywords. As this loop continues to turn, we aim to ensure that the delivery frequency is maintained. As for the overall architecture, there are two main data flows. The process of content submission is from the left in the diagram, when content is submitted to the right. The content delivery platform receives data. We analyze it using a feature analysis platform. We index content and features into the search platform. The content delivery system flows from right to left in the diagram. Then, the backend system of the utilizing service sends a search recommendation request to the search platform via the API of the CDP. The three platforms appearing here are, this is a key player supporting this ecosystem. The three main components supporting this ecosystem. Store and organize. I will organize this from the perspective of utilization. First, the content delivery platform is responsible for storing content. Here, we manage and integrate the content submitted and coordinate with each platform. Next, the feature analysis platform plays the role of organizing. We extract the meaning of the content and add various features to it. And the search infrastructure plays the role of utilizing these. Here, content and features are indexed to respond to search and recommendation queries. These three phases of accumulation, organization, and utilization, the content ecosystem functions through the collaboration of each corresponding platform. Next, as for the system design, I will now specifically introduce the search platform, which is a key player. First, the CDP. And content schema. This defines the field structure, such as content title, body, and metadata. And the feature analysis platform. The search infrastructure is also built upon this content infrastructure. As I mentioned in the previous slide, this is the common language used throughout the entire ecosystem. The second is content lifecycle management. As for content lifecycle management, updates to articles after they've been submitted, or deletion at the distribution deadline, which is responsible for managing content states. The third is the distribution system. It also functions as a gateway for the search infrastructure. This controls the request volume from each service. More details will be provided later. Next is the role of the feature analysis platform. The feature analysis platform, as I mentioned earlier, is a platform that extracts the meaning of content. There are mainly three types of features used. The first is category. This is a classification of content topics. The second is entity extraction. This shows the entity information and the degree of topic relevance included in the content. It holds such pair information. The third is category vectors. This is an embedding vector that numerically represents the meaning of the content. Related to today's presentation, category and content vectors. Categories will be used for refining searches and recommendations. Content vectors can be used for recommendations and searching for similar content. Even for AI-generated content, we use the same analysis pipeline as for article content. Even if the content formats are different, they can still be treated as content with the same metadata from search recommendations. This is the premise for extending the existing pipeline. The component that we have been referring to as the search foundation up to this point, this is the system we call ABIS internally. This is an Apache Solr-based search engine platform. We also introduced this at Tech Fairs 2022. Some of you may already know this. Here, both the content that has been ingested and the features assigned by the feature analysis platform are imported into the Apache Solr index. For search areas, recommend query and returns relevant content for requests. For services that utilize content, the crucial point is that both original articles and generated content can be handled in the same way. I will now explain the key points when integrating the AI-generated content into this ecosystem. The first is about data handling conditions and content management rules. We have also confirmed with the legal department that it complies with laws and contracts under the same rules as existing content. We have confirmed that there are no issues with integrating it into the ecosystem. The second is compatibility with existing content schema. Regarding AICC content, the data structure was not exactly the same. We were able to accommodate this by mapping it to the existing content schema. For example, if we take the Buzz summary as an example, there are no publishers involved. We do define such fields, but this is because it cannot be applied to AI-generated content as is. We implemented measures such as matching strings representing Buzz Matome. The design policy was consistently planned. Instead of creating new types, we will leverage existing pipelines. This is because the existing gaps were abstracted to such an extent that they could absorb new forms of content. We were able to expand it. Next, I will explain our business contributions. I will explain what value and results were obtained. I will discuss the business contributions of this initiative. From the perspective of the three companies' services, primary articles, comment articles, and buzz summaries, these are delivered as results from existing search recommendations. As for specific use cases, Yahoo News is available on the Yahoo Japan app and other platforms. We are able to post comment articles and buzz summaries on the existing main article timeline. This allows for diverse services available, deliver content to users more quickly. This means we were able to achieve this. I'd like to discuss another initiative and its results from a platform perspective. The Content Delivery Platform, CDP, is a distribution network already widely used by both content submitters and referrers. This time, we were able to place AI-generated content directly onto this existing distribution network. As no individual development was required and existing users did not need new onboarding, the ecosystem is structured to accept new content formats with minimal cost. This demonstrates the validity of our approach to extending existing mechanisms. Next, I will discuss platform operations. Specifically, regarding the content delivery platform, what was the thinking behind this large-scale system? I will explain how we operate. First, as a platform team, we are aware of it functions as a bridge between content owners and content users. The content owners on the input side and the content user, who is the user, each has different requirements. For example, content owners want to know if the content they have submitted is being used appropriately. Content users want to deliver content to users as quickly and effectively as possible. That's how it is. The content distribution platform plays a role in mediating the requirements of both sides. Specifically, onboarding new services and adjusting schema requirements. Yesterday, we addressed additional prevention measures. These are the specific tasks that act as a bridge. And as a platform responsibility, how to handle this content. I will explain how we manage this permission. The content that was originally submitted was. This is handled by the submission service and the contracts with media companies. If an in-house service wants to use that content, checking content usage permission becomes the responsibility of the service that uses it. The platform verifies whether confirmation has been properly carried out. We operate by confirming the acquired float approval and then releasing the ACL for content usage. By doing so, we prevent usage from starting without proper authorization. This is not a technical challenge, but rather a responsibility that the platform should bear as an operational mechanism. It's not just about distributing content, but also about ensuring that it is handled appropriately. We believe this is also an important responsibility as a bridge builder. Finally, I would like to introduce two system operation innovations for platform operation. First, we have implemented cluster separation and rate limit settings for each reference service. This is, media-related services are, it is characterized by very large fluctuations in load. Normal operation, also, there are peak and off-peak hours. Furthermore, in the event of push notifications related to life and property, such as earthquakes or tsunamis, we may experience several times the normal peak request volume. The load flowing into a certain platform should not affect other services. And it's easy to isolate the scope of impact in the event of a failure. This is why they are separated by service. The second is the clear division of responsibilities when extending functionality. There are often requests for new feature additions. In that case, is this feature a common feature used by multiple users? Or is it business logic specific to a particular service? First, I will ask about that point. Even if it appears to be a service-specific behavior, if it is determined that multiple users will use it, we have made the decision to provide it as a configurable feature for each service used. Finally, regarding future prospects, how will this ecosystem expand? I will now explain our future initiatives. One of our future initiatives is this is about the Line News Content Initiative, integration. The content delivery platform is this platform was originally built on the premise of Yahoo Japan's services. Content schema is also limited to the Yahoo Japan service format. In integrating Line News, we aim to support a wider variety of formats. We plan to expand content schema. We consider this the first step in expanding the ecosystem to line-related services as well. The second initiative is the addition of the MCP interface. MCP is a standard protocol for interfacing with generative AI. Currently, the AI and API of the content delivery platform it is assumed to be used from the service's backend system. By adding MCP as an interface here, our internal AI agent through the CDP, media content can be directly utilized. This is what we are thinking. This is not limited to adding interfaces. It also expands the content ecosystem users from service backends to AI agents. The design assets of Content Schema and Content ID are also used for calls from AI agents. I believe this is an initiative that will come alive in an interpretable way. Finally, I would like to summarize 2 points of what I have told you today. The key to this content ecosystem is a common ID for service consultation and good content schema design. New content formats also use the same schema, the same pipeline. We were able to use the same platform and decided to treat AI-generated content specially during the provision. The second is the platform, and also a role in promoting content utilization. It also acts as a gate to ensure compliance with the terms of use, acting as a driving force for the utilization of content across many services. We will expand the fixed scenario. Both of these are the platform's responsibility. That concludes my presentation. Thank you for listening.